This is Unit 2, Lesson 1, Scatter Plots and Lines of Best Fit. So first, what is a scatter plot? So a scatter plot, I'm sure you've seen one before, even if you don't know it. It's just a graph used to compare two sets of data. And when we say compare, I'm looking at what's the relationship between these two sets of data, or is there even one? So let's look what I mean by scatter plot. So remember, so I'm going to have something represented down here, some data, and some other data, right? I'm comparing two different sets, whatever they may be, and I'm going to plot them just like points, right? So I could have something like that. And if you look, what's the general pattern going here? Well, it's increasing, right? So we would say they have a positive relationship or a positive correlation, right? And the opposite, again, if I plot all my points, if the general pattern looks something like this, right, for the most part, we're decreasing, so we have a negative relationship or a negative correlation. Right, if you look at the positive correlation, what's going on, as one set increases, so does the other set. Right, and with a negative correlation, as one set increases, the other one decreases, right? So they're going in opposite directions. So if one increases with a negative correlation, then the other is going to decrease. They're going to go in opposite directions. With a positive correlation, if one goes up, so does the other one, right? And then the third type of correlation that we could have is if it's all just kind of crazy, all over the place. I don't really see an actual pattern. Then we say that there's no correlation, right? And so one could go up, and there's really no way to predict what the other one's going to do. Sometimes it goes up, sometimes it goes down, left, right, whatever, right? So we could have positive correlation, a negative correlation, or no correlation at all. And so we use the scatter plot to see what type of relationship that they have. And I have a set of data that we're going to compare cost of tuition, so going to college, cost of tuition to the year. Right, so how much did college cost during a certain year? So I'm going to write out my list of data points. Here's the year, and here's the price, tuition in dollars. So my list goes from 2000 all the way to 2009. So if you want to go ahead and list those out. I started to run out of room. But it goes all the way to 2009. And in 2000, we had $7,895, 8,012, 8,795, 8,124, 9,802, 10,203, 9,915, 11,347, 11,952, and 10,700. And of course, this data would have to be given to you. So how do I make a scatter plot? So first, draw my axes, and I want usually your one of your data sets is going to be time, and that's going to go on your x-axis. So here I have years, and on the other one I'm going to flip it like this, and I want tuition in dollars. Tuition in dollars. All right, so if you look at my data sets to begin with, the year starts at 2000, right? Generally, if this is my x and my y-axis, and this right here is the origin, I'm not starting at 0 and going all the way up to 2000, right? The only part I'm concerned about is 2000 to 2009. So we can represent that on a graph. I'm just going to put this little squiggly thing right here to show that I don't really need that part of my graph, and so I'm going to label 2000, 2001, 2002, 3, 4, 5, 6, extend my graph, 7, 8, 9. And then I can do the same exact thing with my tuition. If you look at the lowest, it was 7,895, and the highest was 11,952. So really, if I had from 7,000 to 12,000, I could contain all of my data. So I don't want to start at 0. So again, I can make like this little squiggly thing right here to show that I can disregard that part. And I'm going to start at 7,000, and I'm going to go in increments of 1,000. Alright, so I'm going to label that on here. This is by thousands. And so I have 7,000, 8,000, 9,000, 10,000, 11,000, and 12,000. So I'm going to go ahead and label 2,000, 01, 02, 03, 04, 05, 06, 07, 08, 09. And flip my graph the other way. No, I don't have to flip my graph the other way. 7, 8, 9, 10, 11, and 12,000. And now this part is just a matter of plotting my points just like you would any other time. And they don't have to be exact because we know what the exact points are here. I just want to get a visual of what's going on. So at 2,000, I have almost 8,000. So just a little bit below. 2001, pretty close to the same. 2002, I got almost up to 9,000. 2003, I dropped back down a little bit. 2004, I was almost up to 10,000. 2005, about the same. 2006, I dropped just a hair. 2007 got me up to a little over 11,000. 2008 got me almost to 12. And 2009 back down almost to 11, so right here. And so looking at my data, you can kind of see that it is increasing for the most part. We get on again, off again, but for the most part, I'm increasing. And so I would say this has a positive correlation. All right, so I drew this line through here. I want a line that gets me as close as possible to all of my points, and we would prefer it if it went through 2 points. I got really close. I'm going to pretend that it went through this point right here, and I'm just going to make that a really big point. And I went through this point right here. And this is just a linear function, so we could actually find the equation of this line. And again, your line may be different than mine. This is just the one I saw. But our line of best fit, we're trying to get it as close to as many of the points as possible. And so I'm going to call this my line of best fit. And we can find the equation again. This is just a linear equation. And so we're going to come over here, and we're actually going to find the equation of my line of best fit. And so again, we're pretending that I actually went through these two lines. And so that was at 2001 and at 2005. And we have our data I can pull from that. And again, your line may be different than mine, and that's okay. And so I want to write the equation of my line where it's y equals mx plus b. M is your slope. So I'm going to have y2 minus y1 divided by x2 minus x1. And so, again, the 2 points that I had were at 2001. So in 2001, it was $8,012. And the other point I had was at 2005. So in 2005, it was $10,203. So I'm going to use these points, 2 points, to model an equation, the line of best fit. And so these are my x's and these are my y's. And so I'm going to find my slope. So I have 10,203 minus 8,012 divided by 2005 minus 2001. And you can kind of check yourself to make sure you plugged in your values correctly. If you cover up one side, you should have your y over your x, obviously, but they should come from the same point, right? 10,203 and 2005, which they did. They came from the same point. And same thing on the other one. I have my y over my x, and they came from the same point. And you can use your calculator for this. So I have 10,203 minus 8,012. Got me 2,191 divided by 2005 minus 2001 is 4. And what does that get me? Divide that by 4. 547.75. So there's my slope. This is M. And now I need to find B. To find B, you can pick just one of your points, doesn't matter which one, and plug them in. So remember, I have y equals mx plus b. If I pick one of my points, I do know a y value. I know m, I just found it, and I know an x value. So I can just solve for b. So I'm going to pick the first point, doesn't matter which one, but I'm going to pick the first one. And so my y value is 8,012. M is 547.75, and X is 2001 plus B, so I want B all by itself, so I'm going to multiply 547.75 times 2001, so I get 8,012 equals 1096047.75 plus B. So subtract this very large number from both sides, and I get negative 1088035.75. Okay, so my equation is y equals 547.75x minus this large number right here. Alright, so now this equation used 2 points to find an equation that models my data. Now, what do I use this line for? Your line of best fit can be used to predict data, not in my data set. And so it's going to change every time depending on what your data looks like. But in this case, what am I modeling? I'm looking at how much tuition costs from 2001 to 2009. And so I could use this equation now to predict how much tuition would cost in, let's say, 2017. So I'm going to use my line of best fit. To estimate the cost of tuition in 2017. And so if you recall, my years were on my x-axis, so 2017 is the next value. And so I can just plug this into my line of best fit to get, hopefully, something that will resemble tuition in 2017. So I have y equals 547.75 times 2017 minus this very large number. And again, I can just pop that into my calculator. Let's see. I get $16,776. And so hopefully that's not true because it's quite expensive, but that's probably a pretty good estimate as far as how much tuition will cost in 2017. So that's my line of best fit. So what is the problem with the line of best fit? If you recall, the way that I drew my line of best fit, it only used 2 points in my data set to find this line that's supposed to model all of the data. There is a formula that you could use by hand that accounts for every single one of these dots, and nobody got time for that. So we're going to go to our calculator. So the process of accounting for every single one of your data points is called a regression. And if you look at our line, our data kind of mimics a straight line, and so the regression that we'll use is called a linear regression. Linear regression. All right, so linear regression uses all data points to derive, we're going to be fancy, to come up with an equation to model the data. And like I said, there is a formula to do it by hand, but it does take a long time. It's very extensive. And so we're going to use our calculators to do this. So the linear regression is done in the calculator. On your homework and in your class assignment, you are asked to do both, so you will have to find the line of best fit and then also find the linear regression and compare the two values. So show you how we do a linear regression in the calculator. So your very first step, you want to go to Stat. So Stat is right here next to the X button, Stat. And you'll see it says Edit, so you're going to press Enter. And you want to enter in all of your values that are on the x-axis into L1 and all of the values that are on the y-axis into L2. So x's go in L1 and the y's go in L2. So take just a second to do that. So in L1, I'm going to do 2000, 2001, 2002, 2003, and you have to push enter after each one. 2004, 2005, 2006, 2007, 2008, and 2009. And then I'll go over to L2 and put all my Y values. Alright, so I have all my Y values. You probably want to go through and just double check that all your numbers are right. Once you enter them all in, you're going to go back to Stat. And then at the top you'll see it says Calculate, and I do want to calculate something. I want to perform the regression, so I'm going to go over to Calc. And right now we're just working with linear functions, so I want to go to number 4, linreg, linear regression. And so you can press the number 4 or go down to it and press enter. And comes up linreg, so I'm going to press enter. And here it gives me an approximation for the equation. So I have y equals A is my slope, so 432.1 I'm going to round to the hundreds. So 48x minus 8572229.23. And so this equation takes into account all of our data points. And so I want to compare our two values. We used our line of best fit to figure out the approximate cost of tuition in 2017. And so I want to use this equation to do the same. So I'm plugging in 2017 for x. So I get y equals 432.48 times 2017 minus 8572229.23. And again, I'm just going to plug that into my calculator. And I get y equals 15,082.93. And you recall when we did it with our line of best fit, we got 16,776. And so I want to come over here and look. If I plotted these two values, so in 2017, you picture this line. I'm going to get my ruler. I picture this line continuing on the way that it is. I'm going to go off the next page just to give you an idea of what's going on. I'm going to say 17 would be about there. Boop. 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 There we go. And let's see, that was 12, 13, 14, 15, 16. So 2017, I don't know, we got pretty dead smack in the middle between 16,776 and what we got with our linear regression, 15,082.93. Your linear regression is definitely going to be more accurate than the line of best fit. And that kind of should be obvious, only because it does account for all of your data points versus just two of them. All right, so again, you will have to do both for your homework and for your class assignment. Your class assignment should be done in your notes. And if you want to pause it and take a minute to go download it, this is it. And we're going to do the first couple together, and then you'll do the rest on your own. So the first one, they already have your scatter plot. So the scatter plot shows the number of CDs in millions that were sold from 1999 to 2005. And again, you can see the little squiggly. They did not start with 0. They started at 650. So the little squiggly just accounts for that. And it wants to know if the trend continued, how many CDs were sold in 2006. So it's kind of our estimate as well. You could go through and figure out the line of best fit, but they just want a rough estimate. And so if the trend continued, it is decreasing. So at 2006, probably somewhere right about here. So I'd say 650 million. So number 2, the table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. So this is their age, this is how much it costs, and again, they already kind of have your scatter plot set up for you, and again, there's the squiggly line. So at 3, I'm at 10,700, so somewhere between 10 and 11. At 6, I'm between 11 and 12. 9, I'm between 12 and 13. 12, I'm at 15. And at 15, I'm between 16 and 17. Again, it does not have to be exact, but you can get an idea what type of correlation do I have here. It should be a positive correlation. And it wants you to draw a scatter plot and describe what relationship exists within the data. So we already said a positive correlation. And so what does that mean? Remember, positive correlation, if one goes up, the other one does too. And so we could say something as a child gets older, I don't know, they become more expensive, right? It costs more to raise them. And that kind of makes sense. You get involved in more activities at school, shopping, things like that. All right, number 3, just asks you to make a scatter plot of the data and draw a line of best fit, and wants to know what is the equation of the line of best fit as well. So I'm actually going to leave that for y'all. Go through the rest of them, make your scatter plot, make your line of best fit, and I also want you to go into the calculator after you find your line of best fit and find the linear regression and answer the questions. Okay, if you have any questions, of course, I'm over here at my desk and I'll be around to harass you as well. So do this. This should be in your notes. I will be looking for it. And you also have a homework assignment, it's just a couple of questions, and that will be due on Tuesday. All right, hope you all have a good day. Bye.